you can easily get, easily get lost in some of the maneuvering, right? But that's something, if you have to take a differential equation, and you have to, in which, as I said before, you have to deal with series solutions, and then you have to do a lot of things like this. So once in a while, I'll show you some techniques that will help you tame the situations when you get to that part of differential equation. Anyway, how about part B? Part B says that, look, let's not do that. So let's do this. Square root x at 16, right? So at 16, so I want to write it as a power series x minus 16. So this guy, I'm going to call it u, which is to say x is equal to 16 plus u, all right? And so this one, therefore, is square root 16 plus u, 16 plus a little bit. And I know that if it is exactly 16, I know I get a nice number, which is 4, right? And this one becomes what? Well, isn't that 16 times 1 plus u over 16? And therefore, this becomes 4 times square root 1 plus u over 16. Correct? That's more manageable. Then you will simply, you don't reinvent the wheel, you just use the binomial series results, and that's all. Right? So you go, okay, this is 4 times 1 plus u over 16 to the, what? 1/2 power. Right? Then what do you get? 4, right? Big bracket, 1 plus 1/2 u over 16 plus, what's the next term? 1/2 times negative 1/2, right? 2 factorial u over 16 squared, right? Plus 1/2, negative 1/2, negative 3/2 over 3 factorial u over 16 third power, and so on, plus dot dot dot. Okay? So what you have then is first term is 4. Is that what we have? Yeah. Second term is what? Is that 1/8? That's what we have, isn't it? All right, u means x minus 16. What is the third term? Third term is minus 4 cancel out 2 factorial. What did I write over there? Oh, next one is start you doing that. So you see that the next one is equal to 2. Good. So the next one is minus. Then the way I'm going to write it is this is you have 2 factorial here. You have 1, and you have 4 cancel out. You have 16 squared. You have u squared, right? And you move on, the next thing that happens is that, first of all, it's alternating. And by the way, the 16 to the second power, isn't that 2 to the fourth power and then second power? Is that right? 2 to the 4th power, and then second power 2 to the what? 8th power? So if you move on to the next term, what happens? Next time you're going to have, rather than 2 factorial, you're going to have 3 factorial, right? And then you're going to have one extra 2 here in the denominator, and also one extra 16. All right? 16 is 2 to the 4th power. So one extra 2 to the 4th power, one extra, that means extra 2 to the 5th power. So this is 2 to the 13th power. Then of course there's an extra u. And then this time you'll have 1 times 3. And the pattern begins to emerge. Okay? So if you look at this one over here, this one, start with 2, you have minus sign. 2 minus 3, that's 1. And then you have 2, that's, what is that, 2 ninths, 2 to the 9th power. Sorry, 2 to the, no, n is 2, so 12, 8, 2 to the 8th power, what power is that? 2 to the 8th, that's right. And then 0 factorial here, 2 factorial here, and this is 1 factorial here. And x minus 16, which is u. So u to the 2nd power. Next one will be plus, and it will be 2 more, so that's 3 factorial. And there will be 1 more, that will be 1 factorial, it will be 3 factorial. And this will be 6 more, 14. And this will be u to the 1 more, 3rd power. Is that right? Yeah, you have 13, but that's because you know, if I have, the trick, remember, is to insert a 2 here, right? And that will give you what? 3 factorial. And then extra 2 here will give you 2 to the 14th power. And then you have 3 factorial and 1 factorial. That's right. Yeah? Okay, just double check, you know. I'm sure you're tired too. So, just to give you an idea, I mean, you don't have to use it, always take the derivative. And so you have to do is, you know, this is the second approach. So what you do is that I want to expand around 16. The Taylor series centered at 16. So usually I use a trick. If you want to center around 16, right, around x equal to 16, then you simply do, you know, x would be 16 plus something. 16 plus an increment. So 16 plus u. So essentially you want a power series in u. And then in the end, you recall that u means 16, x minus 16, and then put it back. And this way you save the trouble writing a lot of x minus 16, right? So it's cleaner. And only before you report the answer, you replace by x minus 16. That's easier, you know, to do the algebraic work. All right? So in general, it could be complicated, but I'm just telling you, if you know this one, as opposed to just use the, you know, the definition, then it's more flexible. You know, whatever way it takes, in the end, you're going to be the same series anyway. So you don't have to always use the definition. Most of the time, perhaps you prefer not to use the definition. That's the message I try to get across. Okay, let's take a break, and after that, I'm going to show